right, we are back. This is Techmath2. We're looking at the chapter 11-12 review. So let's get started. I need a marker. Okay, so we're looking at number 1. Chapter 11, it's y equals 6 sine theta, and then they tell you theta is 30 degrees. So all you do with that is plug and chug. You're just going to type into your calculator 6, hit sine, 30. You can do the end parenthesis if you want, and then hit enter, and you get y equals 3. Number 2, y equals 4 sine of theta plus 30. And they tell you theta is 45 degrees. So again, plug and chug. So you're going to type in 4 sine. You can do the parentheses. Now, if you want to just add the 45 and the 30 and get 75 and put that in, that's fine. Or you can literally type 45 plus 30 and then do the end parenthesis. And then hit enter, and we'll go 4 decimal places. Again, on the test, it'll be clear that how many places we want. So 6, 3, 7. On the review, it's not always forthcoming with that, but on the test, they'll make sure to say round to hundredths, round to thousands, round to 10,000ths. All right, number 3. Using y and theta, write an equation of the fundamental sine wave whose amplitude is 3.6. So, so the amplitude excuse me, is how high up it goes from x and how far down it goes from x. So if it's got an amplitude of 3.6, it would be all the way up to 3.6 and all the way down to negative 3.6. They didn't want you to graph it though, they just wanted you to give the equation. So it's y equals 3.6 sine theta. Don't forget about the theta or x. If you want x, it's fine. Y equals 3.6 sine x. But don't just put y equals 3.6 sine. We need either a theta or an x there so that it's an equation. To have an equation, you need 2 variables, a y and an x, or a y and a theta. All right? So don't forget that. A lot of people focus on the 3.6, which is the amplitude, but they forget to put that part. So make sure not to do that. I want you to get an A on the test. All right, let's keep going here. Number 4. In the following equations, what's the max value? So y equals 10 sine theta. B is y equals 4.1 sine theta. And C is y equals 2 sine 4 theta. And so the amplitude is going to be the maximum amount. So this one is 10, this one is 4.1, and this one is 2. And that's it. So amplitude is always going to be the max. It's also going to be the min, like a -2, a -4.1, -10. But just be aware. Number 5, write the equation using y and theta. When the amplitude is 4.7, and now, so this one, write the equation using y and theta of a sine wave with amplitude of 4.7, which has a phase angle of -30 with the fundamental sine wave. So when they give it to you like that, we got the 4.7 sine, but when they say, you have to read these carefully, phase angle of -30 with the fundamental sine means do -30. So theta -30 degrees. All right. Number 6. This is worded funny. I wrote that a little note on the bottom of the page on number 6. To be in phase with y equals sine theta, the graph of y equals 3 sine theta minus 45 degrees must be shifted. So the 3 is the amplitude. That has nothing to do with the phase shift. it is 45 degrees, and everybody pretty much gets that. But this, if you were to graph it, this would be 45 degrees shifted to the right. But that's not what they're asking. They're asking, how would I put it back in phase with y equals sine theta? So it's actually 45 degrees and to the left. So left is the one that they're looking for there. Even though when I actually graph this, minus 45 takes the whole graph and shifts it to the right, they're asking, what do I have to do to this graph to make it look back like a regular sine wave? And so that's why we're saying the word left instead of right. So on the bottom, I said negative 45 degrees actually shifts the sine wave 45 degrees to the right. But the way they phrase the question, they're asking, how do I get it back to normal? Okay. And so number 7 kind of builds on that same kind of thought process. Let's take a look at number 7. So they give you 2 equations. They give you y equals 3 sine of theta plus 30 degrees, which would be a 30-degree shift to the left. So kind of opposite of probably what your brain is thinking. Plus, normally you think to the right, but it's actually a shift to the left. And the other one is 3 sine theta minus 30 degrees. So that is a 30-degree shift to the right. Now they're asking, how would I move this one and put it on top of that one? So it would be a 60-degree shift to the right in order to put this one on top of that one, because this one was 30 degrees to the left, this one was 30 degrees to the right, so it's a grand total of 60 degrees to the right to pick this one up and drop it onto that one. So that's a little tricky on that, all right? Let's take a look at number 8 for the harmonic equation. So they give you this equation, y equals 6 sine of 3 theta. All right, so how many basic cycles are there? This 3 means there's sort of 3 for the price of 1. A normal sine wave goes from 0 to 60, and that's 1 cycle. 0 to 360, rather. 0 to 360, 1 cycle. That's the norm. This one, there's 3 of them in the space that normally there's 1. So kind of 3 for the price of 1. So you would divide, well, we wouldn't divide anything because the first question says, how many basic cycles are there between 0 and 360? That is 3. So there's 3 crammed in there instead of just the 1 normal sine wave. All right. What is the max value? That's back to the amplitude. So that would be 6 would be the max value. How many degrees are there in a cycle or a period? Well, the norm is 360. But then this 3 is, we divide it by 3. So every 120 degrees, a new cycle will start. The first cycle begins at 0 degrees. At what value of theta does the second cycle begin? Well, that's D. Sort of is asking the same question as C. It would start at 120. You know, that would be 1 cycle and it would start over at 120. For what values between 0 and 360 is Y a max value? Now that one, depending on how visual a thinker you are, some students I've had can just do that sort of in their head. I don't know how. You could use your graphing calculator and type that in, set the window for X to be, 0 to 360, and then, hone in on the top 3 points. I think that's a lot of work, and I think it's a little easier to just do yourself a sketch. So here, we're going to sketch 1, 2, 3 cycles, all right? And now that is 360 degrees. Normally, just 1 sine wave goes 0 to 360, but this time we get 3 for the price of 1 because of that 3. Now it's going up as high as 6 and down as low as -6 because of the 6. So it's higher than the normal sine wave, and there's 3 of them squished in there. Okay. So now we already said every 120 degrees is where it starts over. So at 120, and then at 240, and then it would stop at 360. All right. So knowing that, let's say, all right, I know that's 120 degrees. These are symmetric graphs. It's a sinusoid. So halfway is the 0, that's 60 degrees. And then halfway there, that's going to be the maximum. That happened at 30 degrees. So we have one of our answers. 30 degrees is the first maximum. There's also a maximum here, and there's also a maximum there. Now, from here, you don't really have to keep filling in numbers. You know what I mean? You don't really have to say, well, okay, I'll add 60 and that'll be 180, and then halfway between there is 150. You could do it that way if you wanted to get that second 150, but you could also just say now 30 degrees plus 120 is 150, plus 120 is 270. And so you could do it by just adding 120 degrees, because that's the cycle. You know, every 120 you get the exact same graph. So I think that's easier than doing it on your graphing calculator. You can do it on your graphing calculator and then do max values, but then you have to go, you know, left boundary, enter, and then click it over, right boundary, enter, take a guess and enter, it'll give you 30. And so there's a lot of typing to have your calculator do the answer for you on that one. All right. Let's see. Where are we for 11 minutes? Okay, we can keep going here a little bit. So number 9 and 10. Sketch the graph y equals 40 sine theta from -360 to +360. And so they already have the blank graph for you right there. So this part's easy. It's just a sine wave, a regular sine wave. So there's 360. There's 180. The difference is it's going all the way up to 40 and all the way down to -40. And then we have to do the negative part. The negative part, I need to put like a dot, and a dot. Kind of draw it in there. Trying to make it look as curved as you can. I'm not good at drawing, but if you do any sketches on the test, make sure you try to make them look curved and don't make them just straight lines. Don't just do like ruler straight lines, because that would be the only way that it'd probably take off any points. All right. Okay, so let's take a look at number 10. Sketch y equals 2 sine 2 theta from 0 to 360. Again, this, because there's 2, we get 2 for the price of 1. So you get a sine wave, but then you get a second sine wave in this space of 360 degrees. So now halfway is 180, and then this goes up to 2 and down to -2. The amplitude is always the number in front. Okay. Let's take a look at 11. So in 11, they have y equals 3 plus 5 sine theta. And then they ask, where does it cross the y-axis? Well, that plus 3 takes the whole sine and just shifts it up 3 units. So right there, and then it goes up to 1, 2, 3, 4, 5 more, and down 1, 2, 3, 4, 5. So down as low as that. So our sine wave kind of goes, but it doesn't matter what the rest of the sine wave looks like. They just want to know where does it cross the y-axis. And so that's just 3. That's whatever number is being added to it. So B, I didn't do any work on the sheet. Y equals -7 plus sine theta, just using the same logic. It's going to cross y at -7. Let's shift it down 7. 12 is a little trickier because 12, they say, okay, which one of these is the same as -10 sine theta? So what the negative does on the sine is it makes it open downward instead of upward. It's still a sine wave, it's just instead of starting up and going down like a normal sine wave, it starts down and then goes up. So it's reflected over the x-axis. It goes down as low as -10, up as high as +10. And now they ask, okay, what are all the rest of these? A is y equals 5 sine theta plus 180. They just want to know which ones would exactly be the exact same sine wave. This is not, because it's got an amplitude of 5. That has an amplitude of 10. So A is kicked to the curb. B, y equals 10 sine of theta plus 180. So what that does is it takes the normal sine wave. Let me erase this guy up above here. Let's draw a normal sine wave. Okay, there's our normal sine wave, but it shifts it 180 degrees to the left. So we would take this dot and it would move it here 180 degrees. And then we would have exactly that sine wave. If you picked it up and moved it and dropped it down, we would have that. So B is one of the correct answers. It matches that one exactly. So if I invert it by throwing a negative in front of it and not changing the shift, that's the same as not inverting it and shifting it 180 degrees to the left. All right, let's get C. That's just y equals 10 sine theta, so that is not going to be the same. That would be a reflection over x of that. So C isn't it. D is y equals 10 sine of theta minus 180 degrees. So that takes this sine wave and shifts it 180 degrees to the right. So if I pick up this dot and move it right there, I would end up with exactly that same graph. So D is also a correct answer. E is y equals 10 cosine theta plus 90 degrees. So the cosine curve, let's take a look at what that is. Cosine starts like this, okay? That's the cosine curve, 0 to 360. And 90 degrees would be, plus 90 would shift it to the left 90 degrees. So we would end up with this again. If you took this dot and moved it right there, we would end up with that same sine wave. So E is also a correct answer. And then F is y equals -10 cosine of theta plus 90. Well, that's not going to be the same because all of everything else is the same. It's an invert of that, so it wouldn't be that. So there's 3 answers for that, B, D, and E. And don't worry, there isn't going to be anything that difficult on the test. That one was pretty tough. All right. And we're going to do a part 2.